So greatest common factor. Let me take, for example, let me take two numbers. You probably do these in your head. What's the greatest common factor of 9 and 27? The biggest number they both go into. They do both go into 3. It's not the biggest one, though. 9. They both go into 9. 9 divided by 9 is 1. 27 divided by 9 is 3, right? So GCF is 9. Now, how are you going to approach it if you've got these really big numbers like this 88 and this 484? You probably can't do that one, those ones in your head, right? So there is an approach to finding the greatest common factor. So what you do is you factor it completely down into a product of primes. So for example, 88. 88 is 8 times 11, right? So I'm going to write 8 times 11. But I can go a little further with that. 8 is not a prime number, right? I can keep going with 8. That's 2 and 4, or 2, 2, 2, and 11. Okay, now I'm all primes. You with me on this? I'm going to factor 484. 4 times 121 is 484, but neither of those are primes. So let's factor the 4. That's 2 and 2. Let's factor the 11. Or I'm sorry, the 121. That's 11 and 11. And the greatest common factor will be a product of their common prime factors. So for example, they both share a 2. Let me write a 2 down. They both have another 2. They share another 2. So they both have at least 2 2s, but that's as far as I can go with the 2s. Because the 484 only has 2 2s at most, right? They both share an 11, but that's as far as I can go with the 11s. They don't share any more 11s. So my greatest common factor is 4 times 11. 2 times 2 times 11. 44. 44 is the biggest factor that 88 and 484 go into. Does that make sense? You want to try for 114 and 35? So let's factor 100. Factors of 100 are 10 and 10, but we can go further than that. We have 2 and 5 and 2 and 5. In other words, 4 times 25 is 100. So, okay, so there's 100. Let's go with the 14. 14 is 2 and 7, and that's all primes. 35 is 5 and 7, and that's all primes, right? So, do they all have a 2? No. Okay, do they all have a 5? Do they all have a 7? So what's our GCF? It's actually 1. I could put a 1 on all these. 1 times these is still the same number, right? So the greatest common factor is just 1. They don't have anything else in common. Still with some x's now. So break down the 30x to the 4th. So I say, well, that breaks down at 2 and 15, or 2 and 15. There's all the primes, 2 and 15, 2, 3, 5, and then 4 x's. 130, what's that, 10 and 13? So here's my 10, there's my 13, and that's 6 x's. $60 would be what, 4 and 15? Here's my 4, here's my 15. Oops. So our greatest common factor here would be they all have a 2. Yeah. Do they all have a 3?
Yep.
Almost. Yeah, the middle one does. Okay, how about 5? Looks like they all got a 5. And that's it. So 10 as far as the number is concerned. And then how many at most X's do they share? 4. All right, let's do this one, and then I think I think you guys are probably good with that. We'll move on. We got a bunch of sections we got covered today, so. '60s, what, 5 and 12? Here's my 12, here's my 5, and then I got an A and 3 B's. Eight times 10 B Well, they all have a 2, and they all have a how about variables? Do they share any variables? A's are in everything except the 80B, so that's a problem. And then B's are in everything except the second one. So it looks like we're stuck. That's it. Just no factors, just 10 on that. Okay. All right, so we're going to use that. I'm going to skip down. You guys can read through some of those in the written notes if you want to. But let's get into factoring out the greatest common factor now. So we got this 30x plus 42. What's the GCF of 30 and 42? Can you do that in your head? Yeah, what's the GCF? What's the biggest number they both go into? 6. Yeah, okay, 6. So I take a 6 out, and what are we left with? Make sure you distribute it back and check it, all right? Make sure you distribute it back and check it. There's our 30x, there's our 42. So we're good. So yes, it does. We just factor out the greatest common factor. About 28x and 70. What's that? 7. Let's try 7. So if we take a 7 out, and you'll probably see, oh, wait, 4x and 10. What about 4 and 10? What can I take out of those two? 2. Yeah, take a 2 out as well. So the greatest common factor of these two is actually 14. Yeah, we actually should have taken 14 out. So again, just be careful when you're doing it. When you get to that 2x plus 5, you should have nothing left that you can take out of that 2x plus 5. But the GCF is 14 on this one. Now, if you've got a negative term in the front there, I would take a negative out. So not only am I going to take out a -1, but what's their greatest common factor? So if I take out -1 and 3, good. Yeah, so and what else variable-wise? X, yeah. So I'm going to take a -3x out, and I'm left with Careful. Plus 7. Remember, if you distribute it back, it's got to give you the same thing. So if I take a negative out, it'll change both of those signs. So make sure, again, you don't always check that. All right, make sure it gives it to the original, right? This one, I don't need to factor out a negative out of this one because it's a positive 63x cubed. But what's the GCF here? 21. Good. And how many x's can I take out? 2. Good. And I'm left with plus 1. Yep. Again, you got to distribute it back to give you the same thing. All right, let's do a little different one here. How about let's remove a common monomial factor. What can I take out of each of those? And 1x, yeah. So good. We take an x out. So I'm left with 6 there, 3 there, and just a 1 there. Again, you should be able to distribute that back and get the same thing. So that's the common monomial factor. This one down here I can take out of what? 4, yeah. Yep, take a 4 out of this. Next one. Yes, I go a little further. 8. I can't take an x out because this 88 doesn't have an x, right? Oh, that last one, gotcha. Yeah, take an 8 out, and I'm left with, and we're stuck there, right? This one, let's take a negative out. And what's the biggest number-wise besides a negative 1? What else do I take out? 8. Good, so negative 8. How many x's can I take out? How many y's? 1. So I'm left with good. Again, it's got to distribute back. Notice that'll distribute back and give me negative 16xy squared, right? And then what? Plus 6, good. Yep. All right, let's get into some grouping now. Notice with this I have 2 terms. Here's one term that's being multiplied. That's another term that's being multiplied. Right? It's kind of like 2x plus 3y. The 2 and the x are being multiplied. The 3 and the y are being multiplied. But there's really just 2 terms. There's that term and that term. That makes sense? So when I look at those 2 terms, what do they both have in common? They both have a x plus 19. Yeah, this binomial. So what we're going to do is we're going to take that, think that as like they both have a y or whatever. But I'm going to take that red y out of each of those, and I'm left with x minus 16. Now think about that. If I FOIL that back, this x will, this will go to both of those, and this negative 16 will go to both of those. I know I did the FOIL out of order, but it'll go to both of those. So it's the same thing. You could FOIL it and check it. You could distribute this and check it, and you'll see they're the same thing on that, right? That's called factor by grouping. It's just that it's partially factored for us already. This next one down here, what do they both have in common? Good, so I take that out of both, and I'm left with what? Plus 1, yeah. This one's got 2 of these x plus 5s. Maybe I'll write it out like that. So I take an x plus 5 out of both, and I'm left with yep, x plus 5 minus 11. I should clean that up. So this is what it ends up. Again, if you distribute all that stuff and work it through, you'll see those are the same thing, right? Now let's do it where it's not factored for us. This is factoring by grouping again. Notice there's 4 terms here. So one is the x cubed, one's the x squared, one's a 15x, one's a 15, right? So I've got 4 terms there. So I'm looking at the first two. What I do is I take the first two and I say, what can I take out of those two? X squared. Good. If I take an x squared out, I'll be left with x plus 1. Now look at the next two. What can I take out of those two? Good. And I'm left with x plus 1. Now notice these two terms, they both have an x plus 1. So I take that x plus 1 out. I'm left with x squared plus 15, and we're all done. That's factored by grouping. There's another one. I'm looking at these first two. X squared, good. Then I'm looking at the next two. And now I'm looking at them like, hey, they both have an x minus 5. I can take that out, and I'm left with 3x squared plus 4. And there it is. Do this last one. What are we taking out there? And we're left with the next two I can take out. You notice they both have the x minus 2's, and we're left with, all right.